day 7.
We don't have every class.
So I have you, but you don't have A and B probably, or alpha or something. A or B. Okay. All right. So we are on practice test number 1, and we are doing letter H, 3H. So it says log of 1,000. Now, anytime it says log, you know the base is 10. And if you're not using the calculator for this, which you are not, you need to make these two numbers match, because then they'll cancel out. So tell me about 1,000. What's 1,000? 10 cubed. So this is the log base 10 of 10 cubed. What is the log base 10 of 10 cubed? 3. Now it's easy when Mrs. Ford does it. Make sure you're thinking, I need to make those numbers match. I need to make those numbers match. 2/3 to the negative third. Negative exponent. What does that do? Flip it. So 3/2 cubed, which is 27/8. E to the log base C of 5. Anytime you have E and ln back to back, they cancel out, you guys. Ln is log base C. Anytime you have E and ln back to back, they're done. So the answer would just be 5. You don't have to show any work. It's just 5. Now we're solving some equations, different kinds of equations, okay? A. We had one like this on yesterday's quiz. What do I do? Think. You know what to do. What do you do with that?
You flip the 2 and x minus 2.
3 squared equals
There
x
you
minus 2.
go. 3 to the second equals x minus 2. Now he's calling that flipping. I'm not sure what he means by that, but this is right. At 3 to the second equals x minus 2. So some of you think of that as loop-de-loo. I don't care. However it makes sense to you, that's what you need to do. 3 to the second equals x minus 2. So 9 equals x minus 2, and it looks like my answer is 11. B, we're going down. B. Little bit different kind of problem. Anybody remember what step 1 is? Divide. Very good. So 2 to the x equals 8?
I was doing ECA test.
Good. Hope that went well. So 2 to the x equals 8, which means x equals 3. That's pretty easy. We're on our practice test, Robbie. We are now on part 4C. Any thoughts on this one? Don't get freaked out. Just think about it for a minute. Divide. Joseph, no hats in the building, please. So we're going to divide. All right, now what? This one is a little tricky because you got to remember that ln means log base C. You need to remember that. If you remember that, then it becomes exactly like Nick's problem right here. How would this one be rewritten? E to the 1/3 equals x. And that's it. You're done. E to the 1/3 equals x. Practice test 1. Back of the front page, part 4. Now we're on D. All right, so somebody tell me, step 1. Divide by 36. Now what's 9 over 36? 1/4. Now this is exactly like the quiz problem we did over here. Oh, I erased it. It's exactly like the quiz problem that we just did. In order to do this, these guys got to match. They don't. So 1/4, leave the 1/2 alone, and change the 1/4 into 1/2 squared. Now they match. So now we can say x minus 1 equals 2, so x equals 3. You good? All right, all the way up to E. Okay, now this one, oh, be careful. I got a little tricky with this one. What do you think? This is a problem. It is bad news to have two logarithms on the same side of the equation. Can those be put together so that instead of having two of them, I have just one of them? This is what I want to have. Now, how do I put them together? That's a minus, so these are going to get put together as a division. So, if you have two logarithms, you need to put them together. Since they're being subtracted, they go together as a division problem. Now what do? You do 3 to the second equals x plus 1 over x. 3 to the second equals x plus 1 over x. So 9 equals x plus 1 over x. How do I solve that? Multiply by x. So 9x equals x plus 1. 8x equals 1, and x equals 1/8. It's a hard problem. Got it? How about F? Kind of the same thing going on. How are you going to start this one? See these two right here? You can't have two. You have to put them together. So you're going to have one logarithm. Now, when these two go together, they're always going to go together as a times or a divide. How are these going to go together? Divide, because it's a subtraction, so they go together just like the last one as a division. Now, look at that and look at the one we just did. The first step was the same, but the second step's going to be really different. Because see how this has no logarithm? So you said 3 to the second equals this. What are you going to do over here since there's a logarithm on both sides? You're just going to get rid of them. So 3x minus 2 over x equals x. Can you see the difference between these two situations, guys? You have to pay attention to that. So 3x minus 2 equals x squared. Oh, Lord. What is this? This is a quadratic equation. It's an x squared equation. So I'm going to move everything, get it set equal to 0. I went that way because I did not have a very good first-year algebra teacher, and I'm not a very good factorer. And if I brought this over here, my x squared would be negative, and I can't factor that. I'm so bad at that. So I need to take everything that way so it stays positive. Does that factor? Minus 1, minus 2. So I get 1 and 2 as my answers. Now we already did one sort of like this. See if you can remember. What's ln stand for? Log base e. So if I write it this way, can you think what to do? Loop-de-loo. E to the negative first equals x. What does e to the negative first mean? 1 over e. There she is. Thank you, Mazzy.
Sorry about the past, though.
It's okay. You just helped somebody tremendously. Thank you very much. 27 to the x equals 9. So change 27 and 9 both into 3's. So 3 cubed and 3 squared. So 3x equals 2 and x equals 2/3. What do you think about that? And finally, that very last one, what about it? X squared equals 9. Yep, so log base x of 9 equals 2. So x squared equals 9 and x equals 3. Let's see what else we've got. Write as a single logarithm. Now that means instead of having 2, we're going to have 1. So we're going to put those two things together. We've done that already today, haven't we? This one's a little different. There's something different about it. Can you tell me what's different about it? The 4. You got to do something with that 4. Who knows what we do with that 4? That's right, Maddie Pritchard. She's going like this. That 4 becomes an exponent. So this is log n to the 4th minus log n. Focus.
Just see how much I gotta be in math instead of management next to it.
What do I do? How do they go together? Look, they're being subtracted, so when I put them together, it's going to be n to the 4th over n, and that's it. Now 6 is the opposite. 6 says break this apart. So instead of having 1 logarithm, let's have 2. Pull it apart. Now when I pull it apart, it's going to come apart as a subtraction because this is a division. So I'll have the log of x cubed minus the log of y squared. We're not quite done. See these guys? So 3 log x minus 2 log y. Now, we haven't done some of this stuff for a very long time, so it may be a little fuzzy for you. So get your note sheets out and look at the example problems and practice a few more. All right, now we're using our calculator. So here we go. Does anybody remember how to do this problem?
Log 19 divided by log 7.
Oh, love you, Chris. Perfect. Log 19 divided by log 7. when you have some weird base, like 7 or 5 or 4, something not Tenerife, you can always do the log of this divided by the log of this. And remember, we talked about it. That number will always be on top of that number. So you type into your calculator log 19 divided by log 7. Don't forget to close the parentheses around that 19. And you should get 1.513. Does it tell me how to round? Thousandth. That would be 3 decimal places. So 1513 is right. You okay with that? All right, how about the second problem? Any thoughts on that?
5
What'd you say?
5 by 5.
Yes, indeed. We want to divide by 5. Very good. So 8 to the x equals 12/5. Now, if this said 8 to the x equals 4, I could do that problem without a calculator, because I could turn both of these into 2's, but this is too weird of a number. How do I do this now? What do I do, Robbie?
L on each side.
I either ln each side or log each side, whichever you want. It doesn't make a bit of difference. If there's an e, I always ln. Otherwise, it doesn't really make any difference. If I take the logarithm of both sides, the reason he told me to do that was because what happens to this out in front? So x log 8 equals log 12/5, and x equals log 12/5 over log 8. That is exactly right. So that answer would be log 12/5 divided by log 8. 0.421. Anybody match that? Okay, we're almost done with this test. Problem C. What are you going to do with problem C? Yep, we have a common theme here. We divide a lot, don't we? So we're going to divide. So e to the 3.8x equals 6. If I divide both sides by -2. Now you're right back to where we were a minute ago here. Remember what Robbie said to do? What did he say to do? Take the logarithm of both sides, ln both sides, since there's an e, we'll ln both sides. Now here is the whopping, wonderful, most greatest thing in the world. What happens when you have ln and e back to back? They cancel. So 3.8x equals ln 6. So x equals ln 6 divided by 3.8. Ethan, you paying attention, sweetheart?
Yeah.
Okay. Let's see, I'm rounding it off. Did you get 6.809? Oh, no, that's not right. I forgot a divided sign. Silly me. How about 0.472? Does that sound better?
Yeah.
That's my second big mistake today. Whew. Get it under control here. All right, now for the back page, I promised you I would give you the formulas. So I'll write them up here on the board, and that's where you'll have them. I'm just going to give you the formulas. I'm not going to tell you which one to use or how to use them. But here are your formulas. So read the first question. And then we ask ourselves, okay, what formula do I use? I got to get that figured out first. What formula am I going to use? I'm going to use this one. And I'm using that one because it says compounded daily. So let's see, what's going to go where? The 10,000 is the ending amount. And the 6543 is the beginning amount. Okay, now when it says 1.875%, how do I put that into my equation? Not 1.875. 0.01875. Now what am I going to divide it by? We are compounding daily. 365. And this is a 365. And how, oh, t is my variable. When your variable is up here in the exponent spot, you know at some point you're going to need to use logarithms. Okay, but not yet. What's step one? Always divide. So I have 10,000 divided by 6543, and that doesn't go in. I'm not worried about it. Just that's what it is. 10,000 divided by 6543 equals 1 plus 0.01875 over 365 to the 365t. Right, what do you want to do now?
Put what's in parentheses together.
What?
Put what's in parentheses together.
So get a number here?
Yeah.
Alright, so Chris says I'm a little uncomfortable with that. And I'm okay with doing that, Chris, as long as we don't round it off too much. So that's 1.00005137. Alright. Now what, Robbie? Take the logarithm of both sides. If you wanted to ln, you could, but there's no advantage to it this time. We're going to take the logarithm of both sides. And the reason Robbie wants to do that is so that what happens to this guy? Whoop, out in front. So 365t log this decimal. Got it? Looks terrible. How can I start figuring this out? I need to get t. I'm looking for this. So what do I need to do? I'm going to take this guy right here, log 10,000 divided by 6543, and I'm going to divide him by what? What am I going to divide him by? 365. Okay, so I'll divide by 365. Don't worry about what shows up on the screen. Just leave it there. Don't worry about it. So now that equals t log 1.0005,137. Now, how am I going to get t by itself? This is on my calculator right now. How am I going to get that t by itself? Take this number and divide it by the log of 1.0005,137. And I got 22.624 years. Your job, I can tell by the look on some of your faces, you're getting all bogged down by the numbers. Don't. Your calculator's doing all the work. You want to get this t by itself. Take this number, divide it by 365, and divide it by this. And that will get t all by itself. Anybody else get 22 years? Thank you, Paul. All right, two more, you guys. Two more. Oh, shoot. How much will be in the account at the end of 50 years if 125 is invested compounded monthly? Which formula? Compounded monthly.
First one.
Same one. So how much will be in the account? 125 invested 0.03125 compounded monthly for 50 years. This is the easy one. No logarithm, straight type it in. What's 12 times 50? Let's take care of that first. 600. So I want you to type this in on your calculator. Type 1 plus 0.03125 divided by 12. Why did I divide by 12, by the way? Monthly. Now, once you get that typed in, 1 plus that divided by that equals, raise it, using your little caret button, to the 600th power, and then times it by 125. And you should have $595.13.
What happened to that E?
That problem has no E?
So if not, just leave it as 0.
No, there's no E in
I
it.
mean, just put it in there.
Okay, look, this formula has no E.
We used the compound. I thought we were using.
No, compounded monthly.
Yeah.
Yep, compounded monthly. All right, how long will it take for a population of 1,300 algabites to grow into 3,100 if their growth constant is 0.101? Which formula? Hurt. So it's a made-up thing. So 3,100 equals 1,300 e to the 0.101 t. I'm hurrying because we're about out of time. Does that, all those numbers make sense where I put them?
Yeah.
Now, step 1, divide. So you're going to have 3,100 over 1,300 equals e to the 0.101 t. Now what? ln both sides. And here is the beautiful, beautiful thing. When you ln and e, they cancel, so 0.101 t. And we'll get our answer by taking ln 3100/1300 and dividing that by 0.101. Nobody leaves till we get our answer. ln 3100 divided by 1300 divided by 0.101. Did you say 8.604? And I don't know if that's days or years. It doesn't say, but it's something, right? Make it up. Days, years, hours, months. Okay, now, tomorrow we have, do you have class tomorrow? Yes, and your homework is due tomorrow.